Hey everybody, good morning again. And
Good morning, Professor.
Good morning. Today we're going to be, so we're pretty much done with functions. Today we're going to be talking about a new topic here. We're going to introduce factoring. And it's an important topic. It's really useful in algebra. It helps us solve a lot of problems, including equations, quadratic equations, rational expressions, and other topics. We're going to spend this class and the next class on factoring before we use it to before we apply it to other topics. So let's start by a definition of factoring or finding the common factor. Factoring is called the greatest common factor. So previously we saw that we can distribute or multiply when you have parentheses. For example, this, you have something like this. So if we distribute this, we get 3x, 3 times x is 3x plus 6. So basically this is a distributive property of real numbers, or simply it's a multiplication. So factoring is basically the other way around. So factoring is basically going back from this to this. That's all what factoring is. So sometimes we need to go back for whatever reason. I'm going to see those reasons later. So we need to rewrite the expression in its original form before we multiply, and we call that factoring. So the way that happens is, the way we do that is, so we take the expression, that's the expression, so we're going to try to turn it back into this. So we look at the polynomial or whatever expression we have, and we look for common factors. Okay, for common factors, meaning the numbers or the variables that both these terms, or you may have more terms, these terms have. So what do you see common here between these two here? 3. 3 is common, that's right. 3 is here, and also 3 is here. So we call that a common factor. Nothing else is common. X is not common because X is here and not here. So once you find what's common, you write it down. We open the parentheses. Basically, we remove what's common from these two. We remove it to the front. So if you remove 3 from here, we'll have X left. And this one, we remove 3 from here, we move it to the front. 6 is basically 3 times 2. So if you move 3 to the front, we'll be left with 2. So that's basically what do we do to factor. As you can see, we went back to the original expression. So we went back to this one. So we call that factoring. It's very simple. Again, all you have to do is find the common number or the common letter or both between two terms or more. You move that to the front. You remove it basically from the terms, or in other words, you divide by this. So once you find the common factor, we divided this by 3, we got X. Divide this also by 3, we got 2. And you can double check it. You can, if you multiply it back again, you'll get back to this. So factoring and multiplication are basically two opposite operations. One of them, one takes you to the other. So one undoes the other, in other words. Okay, so that's the whole idea of finding the common factor. It could be a number, or it could be a number and letters, depending on what the expression is. Let me give you another one. For example, 5x to the second minus 15x. So that's again another. We have a binomial. It doesn't have to be a binomial. It could be any sort of polynomial. So again, we want to factor this. You want to factor this into something into some multiplication. It's going to be some multiplication, whatever that multiplication is. Some A times B. Just like here, we took this addition, we turned it into a product. 3 times something. Basically A times B. So we'll look at the term again, the terms, and we try to find what's common, meaning what do they have? They both have at the same time.
5x is common.
That's right. So these two, first of all, we have 5. We'll write down 5. In addition to 5, we have a variable that's common. We have x2, we have x here and here. This one is x2, this one is x1. So x is common, and the one that they both have is the one with the lower power. We have x2 and x1, so we take the one with the lower power as a common factor. That's it, nothing else is common, so 5 and x are common. Again, once you find your common factor, you open the parentheses.
X minus 3.
So we open the parentheses, and basically again, just remove the 5x from both of these because we moved it to the front. It shouldn't be in these two anymore. And the way we do it is basically by dividing. So we take the terms, we write both of them, or all of them if we have more, and we're going to divide each one of them by 5x. So 5x, we don't want it here anymore. We moved it here, so we're going to divide both of them by 5x. This 5x here, the common denominator. Then we simplify. So this is again the common factor. Okay, so it's going to be 5x. We open the parentheses and just divide, simplify like we did with the exponents and the properties of exponents. So this 5 cancels with 5, x2 over x1 would be x minus, and we divide the other fraction. So 15x by 5x, 15 by 5 is 3, x by x cancel out. So we have 3 left. So this expression is the same as this one. This is a difference or a subtraction of terms, but this is a product. We have 5x multiplied x minus 3. We call these factors. That's a factor, and this is another factor. And again, we can easily go back here simply by distributing. So multiplying and factoring are two opposite operations. So this way we multiply or distribute. Okay, so one way we multiply, and the opposite of operation takes us back to the expression is again called factoring. So it's not always two terms, it could be 3 terms or more. Let me give you an example with maybe 3 terms. Let's say you have 6x to the third, for example, minus 12x to the second, plus maybe 18x. Okay, so it's another expression we want to factor. So now we have 3 terms here. So the purpose of factoring again, the purpose of factoring is turning additions and subtractions into a multiplication. Turning subtractions into a multiplication. Also this, we have additions and subtraction. We're going to turn it into some, whatever it is, some a times b. Just like here, 5x times x minus 3. So it's a multiplication. What a product of terms. Okay, so we have 3 terms. Let's start with the number, with the numbers here, the coefficients. What is the common number between all those coefficients?
6.
6, that's right. 6 is common. 2 is also a common factor. 2 is common. 2 and 3 also. We have 6 goes into all, 2 goes into all, and 3 goes into all. But we take the highest, that's why we call it the greatest common factor. So we're going to take the highest number. We have 6, 12, and 18. Instead of taking 2 or 3, which are common factors, but they're not the greatest. There's only one greatest common factor, and that's 6. Okay, that's the first thing you do. So you find the greatest or the highest number that can go into all of these. That's the first step. Now, what else? Do we have anything else common besides the 6? Everybody?
X.
The x. So we have x3, we have x2, we have x1. Which one do we take as a common factor? Which x?
X1.
That's right. Always take x with the lowest power. For the numbers, we look for the highest number that can go into, that's common between all the numbers, the highest one, the greatest. For the x's, we take the one that goes into all of them, which is the lowest one. So x1 is here, is also here and here. x2 is not common because x2 goes into this one, it goes into this one, but x2 does not go into x1. So we take the lowest variable and we immediately open the parentheses to start the multiplication. Immediately open the parentheses. So this is what we call
minus 2x plus 3.
So we call this the GCF, the greatest common factor, or the GCF. From now on, we're just going to refer to it as the GCF, greatest common factor. So once you find the GCF, you write it down, open the parentheses, and basically divide all of these. We're going to divide all of them by the GCF. Let me write the whole thing again and divide each one of them by the GCF. Because we don't want the 6x here anymore, it's moved here. So we got to remove it from each one of these, and we remove it by dividing all of them by the same thing, by the GCF. The rest basically, now we just need to simplify. So 6x to the third over 6x, that's 6 and 6 cancel out. We subtract the powers as we saw before with the rules of exponents. 3, take away 2, so that's x to the second. What else? What do we get from this subtraction here? Everybody, what do we get from, how do you simplify that?
It's gonna be like x squared minus 2x plus 2.
Well, this one here, specific.
Negative
So 12,
Negative 2
negative 2 and x1.
plus
We subtract powers plus, what do you get in the last one? What do you get from the last one here?
plus 3.
Plus 3. So 18 by 6 is 3. And x cancel out. There's no x left because it's the same thing. It cancels out. Here we subtracted powers, subtract powers. Here if we subtract the powers, it will be 0. It will be x to the power 0, which is 1, which we don't need to write. In other words, x, if you have the same variable, the same power, they're gone. They cancel each other out. And that's it. So this is basically the factoring. We just factored this expression. So it was just an addition and subtraction of terms. We turned it into a product. So 6x multiply this. So basically it's some a times b. It's a product of two things, two factors. We call these factors. That's a factor times another factor. And that's basically what factoring is. So factoring is basically turning sums of terms into products. So you can say, you can define factoring in different ways, but one of them is that it is, so factoring is turning additions and subtractions of terms, turn them into a product or a multiplication. A product of terms, product means multiplication. And we do this for a reason. We're going to see later why this is very useful. Again, it helps us solve equations and simplify some complex expressions we call rational expressions. We're going to talk about this later. And that's pretty much how factoring works. It doesn't matter how many terms you have. We just look for a common number first, if you have one. Then you see if you have a common variable or variables. Could be variable or variables. Okay, everybody, any questions so far about these examples? Everyone? I only hear from a couple of people.
No.
This is very important, everybody. In addition to the rules of exponents and the powers we learned before, factoring is probably the second most important topic in this class. And again, it's going to be applied to many other topics. The next, I don't know, 3 or 4 classes, maybe 5 classes will be based on factoring. So in order to solve a lot of other things, we're going to be using factoring. 80% of the work will be factoring, and then the last step or 2 will be doing something else. But it's going to be based on this. We're always going to be factoring first. Factor whatever expression, then solve or simplify or multiply whatever the problem might be. Let me give you another example here. So you may have more than one variable. So you could have, for example, maybe 9, a couple of variables, some 2 and 3, plus another term and a couple of variables again, 5, for example, 5 and 2 here. Same thing, we want to factor this. Again, factoring, another way, another definition besides this one, factoring is finding common numbers, common factors or common numbers and letters, common numbers and variables. Okay, that's another way of defining factoring. Also, another way is factoring is the opposite of multiplication or finding common numbers and variables. Also, we turn additional subtractions into a product or a multiplication of terms. Same thing here. Whatever we did, we can do to terms with multiple variables. First, again, start with the numbers. What is the common factor or the highest common factor for these numbers, for these 2 terms? With the numbers, what's the common factor?
9.
9. That's why we have 9, we have 8, 18. The highest number that goes into both is 9. Not 3. 3 is a common factor, but it's not the greatest. It is not the greatest, it's not the highest. So 9 is the greatest common factor. What else do you see common besides the 9?
X.
In the second, and
The x, that's right. We have
X squared and Y squared.
That's right. So we have x squared, x is common. We have x2 and x5. Again, take the lower one, x2. Then for the y's, we have y3 and y2. Again, we're going to take the lower out of the 2. And that's it. That's our greatest common factor. It is important to find the greatest common factor, the right one. If you don't find the greatest common factor, you may have to factor again. If you, for example, if you use 3 here, if you use 3 instead of 9, you will have to repeat the work. But try to find the greatest common factor so you factor once for all, and you won't have to factor again. All right, what do I write after the common factor? What comes after the common factor?
parentheses.
The parentheses. Okay, you write the parentheses. What else? What do we do now?
It's gonna be X.
Y, no, Y,
So what is the operation that we do with these and the GCF?
I understand what we do, but I cannot explain what is it.
No, it's the name of the operation, just like here. So what do we do with these and
Here's some
GCF? We divide.
simplify.
Divide. So we take, you find the common factor. Now we're just going to divide. So write both of your terms or all of them. Just write them down just like here. Write them down, and then we're just going to divide one of them. You could do it right away. I understand some of you want to do it right away and write the answer. That's fine. Or it may help if you write them out first so you can clearly see the variables and terms. So once you find the GCF, you divide all the terms by that GCF. Just write the exact same thing here under each one of them. and simplify. So we learned how to simplify this before. So the GCF stays there. Okay, don't forget about the GCF. It stays there.
So it's gonna be y plus 2.
So 9 and 9 cancel out. X2 and X2 cancel out. And Y3 over Y2 will be Y3 over Y2 will be
Just
Y.
Be y.
Right.
Because
Just Y or Y1, same thing, plus. Then simplify this one again. What would that be?
2x3.
This would be
2.
2. Okay. X5 over
X3.
X2.
That's
X3.
it.
That's right.
Y3.
That's it.
Y2 and Y2 cancel out. So Y2 and Y2.
Yeah,
Again, when we divide something by itself, it cancels out. So there's no Y here. And that's it. That's the factoring of this expression. You turn it into a product, something times something. And we can easily check. You can check your factoring by distributing. If you distribute, you should get back to this. You get back to this same expression here. So it works the same way, no matter how many terms or variables you have, find the greatest number, common number, and then see what the common variable is. If you have a common variable, and take the variable with a lower power. That's the one that they all share, they all have, not the highest one. The highest one, only the highest term has the highest one, but it has to be in all of them. So that's one way of factoring. We have 3 other methods of factoring when this one doesn't work. If this one doesn't work, if you don't see a common factor or a number, we have other ones to try after this one if it doesn't work. That method is called factoring by grouping. So factoring by grouping, we use that when the GCF or when we don't have a GCF. That means when you don't see any common number on letter between terms, but you still want to factor it. You still want to turn it into a product. For example, 3x plus maybe 3y and maybe plus ax plus ay. Always again, try to find a common factor. That's the first thing you want to do. Try to find the GCF or the common factor. We have 4 terms here. Do you see a common number in all of them? A common number that's in all of them?
3 x and y.
Is there a number or a letter that's common in all of them?
3x.
1.
Only one is common, right? Only one, the invisible one. But that doesn't help. So we have 1 here and here and here. Other than that, there is no common factor. It has to be in all of them for something to be a common factor. It has to be in all of them. So there is no common factor here. So that's what we need to factor by grouping. Factoring by factoring. It's not factoring by factoring. Factoring by grouping. So that's when we look at them, what we see is like these two have something in common, these two have something in common. So we can group them. We can factor these two together and then factor these two together and see what happens. So forget about these two now. Let's factor these, same way we did here. What is the common factor between these two?
3.
3. Right? 3 is common. Okay, and then we open the parentheses, and again we divide both of these by the common factors. So what do we get inside? So again?
X plus y.
X, that's right, X plus y. So again, you find your GCF and you divide 3x by 3, we get x, divide 3y by 3, we get y. So the first group is factored. Let's move on to the other group and do the same thing. So what is common? What do you see here? Common between those two? The A. So we're going to factor
X plus y.
That's right. We're going to factor the A out, open the parentheses, and again divide both of these by A. Divide AX divided by A, just like we did here. Except we didn't write the division here, we just divide right away. It's pretty simple. So AX divided by A is X. AY divided by A is Y. So basically, we grouped. We did these two together, these two together. Now we are here. We're down to two terms. We have one term plus another term instead of four terms. Among these two terms, what's common? What's common among these two terms?
X, Y.
That's right. This whole thing is the same. So we have xy and xy here. So now that's the common factor for the two. That's the common factor, the new one between the two terms. So again, when you have the common factor, when you find it, you write it out first and you open the parentheses. That's what we're going to do. So this is the common factor, x plus y. Once you find the common factor of the GCF, you open the parentheses. So we're going to open the parentheses. And what is the operation again that we do with the terms and the GCF?
3 plus A.
That's right. So once you find the common factor, you divide all the terms by the GCF. You divide all the terms by the GCF or the common factor. So here now we have the GCF, which is x plus y. So we're going to divide both of these by this. So if you divide this by this, you're going to cancel x plus y, you'll have 3. And the other one also the same thing. If we divide this by x plus y, so the x plus y and x plus y cancel out, you'll have a by itself. And that's it. As you can see, we have factored this, so it looks now like a product. Okay, it looks like a product. This multiply this, and again, that's the purpose of factoring. It's turning addition and subtraction into a product, and that's what we did. We turned addition and subtraction into a product or a multiplication. Even though we didn't have a common factor for all the terms, we were able to factor using grouping. So first, try to find a common factor for all the terms, if possible. If you don't have one, then we try other ways. One of the ways we try is this one, factoring by grouping. We have another one. We have two other methods actually. So factoring by grouping. We try this one, and if that one doesn't work either, we have a couple more. We're going to talk about those next class. So today we're only going to be talking about GCF, this, and grouping. Okay, so again, make sure for something to be a common factor, it has to be in all of them. You have to see it in each one of them. X is not common because X is not here and here. A is not common because it's not here and here. 3 also is not common. It's only in these two, but it's not here. So the common factor must be in all the terms. Like here, we see it in each term. That's why it's called a common factor. If you don't see it in each term, it's not a common factor, then you do something else to factor. Okay, everybody, any questions about the grouping? Everyone?
No, good.
Okay, everybody else? Only hear from like 3 or 4 people. The rest have no idea if you're here or not. Everyone, please feel free to ask questions, participate. This is again very important. Almost every class we're going to see from now on will involve factoring. So you'll have to factor first, then do something else. So if you don't know how to factor, it will be very difficult to do a lot of these topics. So make sure you understand this. It makes a lot of the problems and topics really easy. A lot of it will be factor, and we do something else at the end. But this is really important in addition to the powers, like we said before, the powers and exponents. So let me give you another one, another example of these. So you may have, for example, 5a minus 5b plus CA minus CB, for example. Again, that's we want to factor this whole expression. So that's addition and subtraction, and we want to hopefully make it into a multiplication of 2 things. First, again, try to see if we have a common factor. Do we have a common factor here for all these terms?
A and B.
For all the terms at the same time.
No,
Do
for
they
all of
have,
them, we don't have one.
One.
there's
We
nothing
gotta,
common. That's right.
we gotta group them.
That's right.
Yeah.
So,
The
so
first
there's
two
nothing
tests are
common between
5.
all of these. That's right.
The
So
first
other
one
than
is
one,
5.
It's gonna be
Okay.
5 parentheses A minus B plus 6 parentheses A minus B.
right, right. So first, there's no common factor for all of these. Then you think about, if you notice that there is a couple terms that have something common, then a couple other ones have something common together. That's when you think about grouping. Usually involves two and two terms, 3 and 3. It involves two groups of terms. So these two have something in common, so we can do these two together before we do these. So 5, open the parentheses again, just move 5 to the front. We move the common factor to the front. In other words, it's like dividing both of them. So if you move 5 from here, you move 5 from here to the front, you end up with A minus B, or divide both by 5 plus. Same thing here. So we move C to the front. What we have? C, we move to the front. What do we have inside the parentheses now? Everybody, C is a GCF. Some reason, I think I lost the audio.
Minus B.
A minus B. That's right. All we had to do was move this to the front or divide. So this is the common one. We divide both by C. Okay, that's the first step. We grouped. What else?
Then parentheses A minus B
Mhm.
multiplied to
It's gonna be A minus, yeah.
That's right. So now
X
this is the
plus
new.
C.
This is a new common factor.
5
So
plus C.
this is new. We call it GCF because it's in both of them. So again, we move it to the front. Same way we moved 5 to the front here. We wrote A minus B. Now these new terms, they have A minus B in common. So we move it to the front. You open the parentheses. And if you move this to the front, or if you divide these two, you get 5 left. Plus, same thing here. If you move A minus B to the front, which is here, you have C left. Or you can divide this by this. You cancel A minus B. And that's it. This is our product. How do we check? How do we see? How can we make sure we got the right factory?
We just keep multiplying them, and if we get the first expression we had, we're right.
That's right. So again, this way, we said we called it factoring. To go back, it's very simple. We distribute. We distribute like we did with the binomials. Multiply, multiply, then combine like terms. We will get it back to the exact same expression if the factoring is right. So factor. The other way around is to distribute. So it should be pretty simple. Again, at least we can check for yourself and see if you got it right, simply by multiplying. So basically one way we learn these couple of rules. If you multiply, when we multiply something, we add the powers. This is distributive property. Distributing or multiplying. When you go back, basically we divide them. When you go back, we divide. And that's when we subtract the powers. So this one is for multiplication. When we factor, as you noticed here, we divide and we subtract the powers. X, we do X minus B. So these are the main rules used in, this is for factoring, this is for multiplying. Because they're opposite operations, one way we divide, one way we multiply. Because also division and multiplication are opposite operations. The opposite of dividing something is multiplying it. And for these problems, this is what we use. If you distribute, you're going to be using this and adding the powers, or here, for example, if you distribute this. But again, to go back, we basically divide and we subtract the powers. So these, again, this is what I said before, that the rules of exponents are very important. And this is another subject where we use the rules of exponents to factor, and factoring itself is used for other things. So the rules of exponents, all 6 or 7 of them, the list we studied before, in addition to factoring, are the key to this, to pretty much everything in this class. Factoring and the rules of exponents. And factoring is basically going backwards. So we subtract the power. So I believe I mentioned before that if we know the rules of exponents, it would make it easy to solve and understand this. As you can see, we use basically the rules of exponents here to factor by subtracting the powers. Okay, everyone, any questions about the factoring by grouping? Please let me know. It is pretty simple and it's very useful. It makes, like I said, some complex things really simple. Once we factor, we can simplify some complex things, turn them into something much easier. Let me see, give you probably another example here. So that's basically factoring by grouping works. So you may have, for example, a few variables. I don't know, you may have X, Y. It's possible to have some variables like these and maybe a number somewhere here. No, we did that already. So that's pretty much how factoring grouping works. You just basically combine, not combine, but group each 2 terms together to make a common factor. Let me give you another example if possible. 2x, for example, minus 6. Okay, 2x minus 6, maybe another one. Possibly 6. Maybe x minus 3. We can multiply this, for example, by 3. Make this 12 or 9. Something like this. So again, we just group terms together, but actually this one here, you may combine like terms first. So before factoring, of course, you'll have to simplify as much as possible. So this you would need to factor because you could combine like terms first, 2x and 3x, and you combine these two, you wouldn't have anything to factor. By the way, some things can't be factored. Some things can't be factored. Sometimes you don't have a common factor, which is fine. For example, we have 3x plus 7, and you want to factor this. There's no common factor here, no number, no letter, so that's fine. We call this a prime polynomial. Not everything can be factored. Okay, sometimes there is no common factor, no GCF, no grouping can be used. So we call those prime polynomials. Give you an example. I'm sure you heard of prime numbers. So for example, 15, we can turn 15 into a product. We can write it as 5 times 3. We call these factors. So these are the factors of 15, 5 and 3. Other numbers can't be factored. We call them prime. So prime numbers are these numbers that we can't break down. We can only basically divide them by themselves and 1. So 17 can't be broken down into integers. So we can just say 17 times 1. So this is a prime number. This is a composite number. Okay, composite number means we can break it down. If not, if it's prime, it's a prime number. Prime numbers, again, we can't break them down. We don't divide them. We only divide them by themselves and by 1. But 15 here is a prime because you can divide it by 5, you can divide it by 3, you can divide it by 15 itself, or by 1. So same thing applies to polynomials. If you can't find a common factor, If you can't find a common factor, that's fine. After you try everything, you can basically just say it's a prime. But after you try everything, after you try this, and there are 2 other methods we're going to learn in the future. So we're not done yet with factoring. We're going to learn those. So if you try all those 4 and nothing works, so in that case, we can say this can't factor, and we can leave it as is. Okay, everybody, any questions about any of this, the GCF or factoring by grouping? Please let me know. Again, this is really interesting and important. It is also pretty simple as long as you know
Professor,
your
So what should
powers.
we do? What should we do next with the last composition? 3x plus 7.
It stays like that, so you can't factor it. It just stays as it is. Let me give you a couple of examples. Give you a couple of these to do by yourself. So we're not going to talk about the other 2 yet. Let's just focus on these for now. We'll talk about the other 2. The other 2 actually are, they can be simple and they can be tricky, but we're going to talk about those. We'll talk about those next. Those are special. We have special formulas when these don't work. These 2 don't work. We have some special formulas that we can use. That can we can use to factor even if we don't have GCF or we can't use grouping. Okay, so let's do a few of these problems here. All right, so set prime factors, prime numbers or polynomials don't factor. So after you try everything, if it doesn't factor, that's fine. And let me give you a few. So factor, negative, okay, so we have a binomial here, maybe another binomial. A minus maybe 3b. Again, it could be not only binomials, could be any number of terms, but the method is the same. So let's say 5x okay, everybody, so try these. Give you a few minutes to work on these. 25x to the second plus 10x.
Professor.
This,
But, yeah, I have a question, Professor. Can I leave early because I have to be at ASA
Okay.
around 12:45? Sorry about that.
it's okay.
I have to be in. Thank you so much.
Okay, no problem. So we have this, and let's say and finally, another example here would be, for example, 7. Okay, so this should be enough. Yeah, so again, take a few moments to work on this. It is very important to know factoring because again, everything in the future will involve factoring. So it can be very useful. If you know it, if you don't know it, it's going to make things even harder. And we wouldn't be able to do much if we don't know factoring. So please make sure you understand factoring well. These 2 and the next two methods we're going to learn. And again, don't forget about your exponents. All of this, basically what we've done today was based on exponents. So make sure you review those rules constantly to be able to use them. Okay, I'll give you a few minutes to work on this, maybe 10, 12 minutes or so. You may as well take a short break if you would like to, before or after the practice. Okay, so I'll see you again in a few minutes. Everybody, we're done.
Yeah.
Okay, everybody else? Everyone, are you done? Hello, everybody else. There's more than one person, I believe, in this class.
Yeah, I'm done.
And
Okay,
I'm done.
all right. Okay, everyone, so let's go over these problems together. So the first one here, what is the common factor?
I got negative 3x parentheses x squared minus 4x.
Okay, negative 3x squared.
Parentheses.
Parentheses x squared minus 4x.
No, only x minus 4x.
Let me write it down here. So the common factor is negative 3x
Yeah.
to the second.
Yeah,
Then we're going to divide
so-
these two.
x minus 4x.
That's right. You divide these
Minus
two to get
4.
x.
but why is it negative?
Um,
Common is not
It
negative.
can be positive too, but you
Be
got
positive or negative.
minus
So
on the x.
if you multiply, you'll get a negative. If you multiply these, you get a negative. But this has to be a negative too. So you multiply them, you get a positive. So you can also use a positive, but as long as when you distribute, you should get this and this. So if it's a negative here, you multiply, you get negative 3. If you use a negative here, this has to be a negative. So when you multiply them, you should get a positive.
So also can use positive, right?
If you use positive here, then you would have to use a negative here and a positive in this one.
Yeah, I got it.
Either way, so when you distribute, we should get the same. So now we're going to divide these.
4x.
It'll be 4, just not 4x and just 4. X to the second by x to the second, they cancel out. There's no x left. Okay, so that's the first one.
Why?
This one. Okay, this one, what is common between the two?
But it's 12.
3 parentheses
Oh, I see. Okay, got it.
minus
So again, if you distribute, you should get this. If you don't get the same thing when you distribute, then something is wrong, either a sign or a
Right,
power, you have to fix it.
I'm writing down wrong in my paper. Okay, thank you. I
Mhm.
didn't see the power thing.
Okay. Next one, what is the common factor here?
3.
3. Only 3 is common, so we're going to write 3. And again, divide both of these by 3. 12a divided by 3 would be 4a minus, again, 3b divided by 3 would be b. That's it. And again, you can check your factoring easily by distributing. You should get back to this.
1B is still
1b is fine. You can say b or 1b. Okay, so the next one, this time we have 3 terms.
The
What is, okay, start with the numbers, or what is the GCF? What is the GCF for all of them?
5 and x. 5x.
X, it's a common.
That's right, 5 and x. 5 goes into all of them, and x with the lowest power is the common factor.
Goes x on the
x
second.
squared
That's right, so we're going to divide all of these by the GCF.
X to
If
the
we divide
second.
these, we get x to the second minus 25x to the second by 5x. and
5x.
That's right, and 10x by 5x. And b,
2.
Only 5.
2.
2.
Mhm. 2. That's all. And again, if we distribute, we should get exactly the same expression. This one here, we have a couple of variables. Well, what's the GCF here? What's the common factor? Everybody, what is the common factor?
I took 4x2y. I know it could be
You
negative.
can use 4. You can use 4, x2,
can be
and y.
negative.
Can be a
x2.
positive. So now we just divide this by this, whatever the sign comes out to be, you put it here. So if you divide -4 by
Professor, you
4,
put X, Y exposing 2 and Y. It's
Um,
X,
yeah,
X.
yeah, right, X and Y. So X, we have X3, X2. And we have Y1 and Y7, so Y1 is the common factor.
I have a question, Professor.
Again, whatever sign you decide to use here, just divide these, divide those, and whatever the sign you get from the division you put in.
Okay,
So what do we get from here? We divide -4 by 4 would be,
minus
Minus X plus
Mhm.
3Y6.
that's right. So X3, X2 is X, Y and Y cancel out. Then again, divide plus by plus would be plus. 12 by 4 is 3. X2 cancel out against X2, and we have Y7 over Y1,
y to the 6.
Y to the 6. And again, if you distribute, you should get exactly this, same signs, whatever. So play around with the signs or the powers. You can use a minus here or not, but when you distribute, the results would be the same. It's like saying, for example, -12 times 3. It is the same as 3 times -12. The end result is the same, -36. So it doesn't matter where you put the minus here or there. Same thing here. So as long as the result is the same, whether you multiply these or these, you should get the same result. Same thing here. It doesn't matter which sign you use, as long as you get the same result when you distribute. That's good. The last one here. What do we do?
it's gonna be like, gonna distribute it.
Here.
Gonna be
Okay.
First step, I put it.
the A minus C plus X is A minus C.
Okay, so there is no common factor, so we use grouping. We do these two together. We have 7 in common, so 7A minus C. And these two also together, we have, what do they have in common? Nothing, right? 7A minus C, X. What did I put here? I should have put X here. I put X. So in this case, you can only.
That was my
Um,
question, yeah.
mhm.
Or did mistake or,
Yeah,
There's
so in this
no-
case, so these two we factor together.
yeah, because I'm
There's no common. There's no common factor here, so these would stay the same. But what I meant to write was, I meant to write X here. So
that's
this is what I meant to write in the original problem. So now these two, let's see. So these two can factor together. These two also can factor. Where is the common factor here?
So it would be 7
Plus
plus
X,
X.
X is a common factor. Okay, open the parentheses.
A
And what
minus
do we get inside?
A minus C.
A minus C. Okay, what else now?
7 plus.
it's gonna be parentheses A minus C, parentheses, 7 plus X.
So the new common factor now between these two is A minus C. And again, if we remove it from here, move it to the front, we can have 7 minus or plus X left. And again, you should be able to check if we distribute, should be able to go back to this expression. So again, factoring is just the opposite of multiplication, so you can check it by distributing or multiplying. Any questions, everybody, about factoring? Again, this is very, very important. It's really not that hard. It's pretty simple, but it's very useful. So again, make sure you understand all this. And the next two methods. There's 2 methods today. We're going to learn 2 more next class. And then we'll see how to use them. I'm going to use them for at least maybe 4 classes, 4 lectures, or at least 4 lectures after that. Any questions, everybody?
Professor, the midterm exam